and Learn live on LinkedIn and on YouTube on lunchtime East Coast time in the US. Today's topic is simulation for fuel cell and electrolyzer optimization. And I'm here with my colleague Jun Lee. My name is Thomas Glatz, and yeah, we will jump right into it and start with a quick intro of AVL for anybody that's new. Then go into the simulation topics. Today we have PEM fuel cell, PEM electrolyzer, solid oxide fuel cell, and also solid oxide electrolyzers. And we will mix it up today a little bit with some live demonstration of the software with live Q&A as well. As always, you can post comments in LinkedIn. And we will wrap it up today with an overview of the upcoming fuel cell events. So the next couple of weeks will be quite intense from a fuel cell side with two conferences coming up that are worth talking about. With that, we just the overview we do every week for everybody that's new. AVL is a very research heavy company since 75 years. And we do engineering, simulation, and testing, and both Jun and I are with the simulation group of AVL. We have quite an extensive portfolio, and specifically for the fuel cell topic, we will be talking mainly about two products, just to give you an overview. This is AVL CruiseM, the system simulation tool, typically for faster than real-time multi-physical simulations. And we will also be talking about FireM. This is high-fidelity 3D CFD code. Yeah, what kind of simulation are we performing in the fuel cell space at AVL? What topics are we covering? This is on the one hand PEM fuel cell, mainly for mobility applications. We also perform solid oxide electrolyzer and fuel cell. This is a little bit more on the energy, stationary energy topic, industrial green energy, and also we are looking into PEM and AEM electrolyzer simulations. As mentioned, we mainly look or use two tools for the simulations we perform. That's 3D multiphysics CFD in FireM, that you can see here on the left side, and on the right hand we have system simulation where we more look into the interaction of the components rather than the detailed of the specific stack. But to really give you an overview of what that means, I will ask June to share the screen and jump right into FireM.
Absolutely. Thanks, Thomas. So here you can see our AVL 3D simulation tool FireM GUI. So in this GUI, you can create new project, or you can open existing, for example, examples. So in our AVL database, we have a bunch of fuel cell related examples. The simplest one is the straight channel, and then we have the low temperature PEM fuel cell cooling, and also we have two different approach. One is discretized channel, MEA, and also another one is homogenized approach, which is treating the channel as a porous media, so that will save a lot of mesh cells and then save the computational resources. So MEA, with that approach, we can even simulate a small stack, which is also shown here as an example. And then we have some, again, low temperature PEM fuel cell degradation and then transient simulation examples here. And we've also got an electrolyzer and some other related ammonia cracker, and we also have some solid oxide example here is not in the installed here. I didn't download that, but you can also look into the online examples to find what else is missing. So in this FireM, you have the solid oxide electrolyzer and stack, and then fuel cell also. And then we have some humidifier and stuff like that. So I'm just going to walk you through a little bit about our FireM setting. On the this is the straight channel simple case. So in this setting, we have first of all we have some model check, which will automatically check the model setting. If there's any problem, you will see this warning on the data check session. So yeah, this is the mesh part, and then this is a simple steady state simulation. So in this simulation, we have only one selection called the MEA plus the flow channel. So everything is in this domain. So if you have the cooling channel and everything, and or a stack, you will also see that in parallel in the domain side, parallel to this MEA plus flow channel. So the first thing we need to specify is this material for this simulation. So we have three material: gas, liquid, and solid. And then in terms of the solid part, we have the GDL and the catalyst layer, membrane, and also for the GDL and for both anode side and cathode side. And then you can specify the solid material. Either choose from a database. For example, I show it in the material session here, and then the user can copy this and then copy paste and then modify according to their own needs. And then there's equation control. We're basically controlling, for example, this electric potential. We're solving only on the solid phase. And then we have these modules. So we have 4 modules in this low temperature PEM fuel cell case. We solve the potential in the GDL and the catalyst layer, and then the also ionic current density in the membrane and also catalyst layer. And then we have this fuel cell model, which we specify where is the channel, where is the terminal, and then we specify also the operating conditions. In this case, we use the voltage. You can use a predefined voltage 0.6 volt, or you can use via operating current density to specify a current density. And then this start with, so this simulation will start, if we activate this one, it will start with the open circuit voltage and then goes down to 0.6 volts. So this way, the simulation is always stable. And then we have some parameters for the fuel cell, and the user can specify. And then we have the degradation effect. Here in this case is not activated, but the user can, if they're interested, they can activate the degradation effect for either for steady state to looking at the membrane degradation, or they can look at with the transient simulation, the other like catalyst layer degradation in the cycle conditions. So, and then we can specify the 3D and 2D results output. And again, we're solving the multi-phase flow in this PEM fuel cell. So these are the multi-phase flow settings, specifying the mass interface exchange, momentum interface exchange, and so on. So the last thing would be the species transport for the gaseous flow. Yeah, and then we have the solver control. So basically everything you can set based on some template. For example, we have this fuel cell performance template. You can use it to set this simulation up. And then we specify the boundary conditions and then initial conditions. Basically, that's what you need for this case. And then you can start the simulation and monitoring what's going on during this simulation process. And then after simulation is done, you can look at the results. So these are some pre-prepared results in this example. So the user can look into the 3D results by the playing card. So this is the oxygen mole fraction from inlet to outlet at the cathode side. And then you can look at, for example, the liquid water saturation in this in different areas. And yeah, you can also look into some of the 2D results. The operating current density versus the voltage change over this simulation process from beginning the open circuit voltage to 0.6 volt. That's the thing which we achieved in a little bit more than 1200 iterations. So yeah, that's so once the user have this case, if they rerun some other cases, they can set this post processing as a template, and then just load in the template and then apply for different case. So that will automatically generate the results for the new cases.
And
So
we get a lot of results, obviously, in 3D. So a lot of result size also. And this is why you, I think, showed earlier the selection of results, because there were so many, right?
yes, definitely. Yeah, there are a lot of, you can already see here, the 3D results side. You can see all the, basically this is a PEM fuel cell is a pretty complicated thing to solve. So there are a lot of results in here, the temperature, potential, and the species, and then the water. So yeah, so basically we use the 3D can help us to basically solving for example, the flow or media non-uniformity issues, and then to look at the water and heat management in a single cell and then in a stack. So and then look at the local degradation effect in this 3D settings. Yeah.
And
So
Jun, you would typically, how far would you go? Would you go up to the full stack in that setup?
So, yeah, this depends on your computation resources. So with, let's say with a full stack, if it's like 100 cells, 200 cells, that will be very challenging with the, so, but we have an example with a short 12 cell stack, so that we can easily solve in this in this tool.
Yep. Perfect. Yeah. I mean, that's for sure a good tool to optimize your design, your dedicated CAD model potentially and find any problems. Yeah, thank you, Joan. So I will quickly jump back to the other side of things, basically to the integration side, and also give you a glimpse of that. If that works, yeah, there we are. So now we are in CruiseM and very similar. And let me just fix this layout very briefly, quickly. There we go. There we are in CruiseM, and similar to what June showed on FireM, we have a couple of installation examples as well. Here for the vehicle, but also for the single fuel cell system to go into stack or balance of plant. But if we start with the vehicle, and let's say we just use this fuel cell truck example here, you see already this is a little bit different. We have no CAD model. We have different components of our fuel cell bus here actually. And you will see we model all other components as well. So the battery, the wheels, the brakes, the strategy as well. And if we go into the actual fuel cell system, we see the stack here in the middle. In this case, it's a much simpler component than just the complex geometry that Jun showed. But you will see a lot of similarity to what he has shown. Basically, the reaction equations and the reaction parameterizations are the same. It's a little bit simple geometry-wise, just to put in the inputs, but you will get a simplified, fast-running version of it. So basically, we have also a workflow to transfer the FireM model, the complex 3D CFD model, into such a simple block. Basically, there's an automatized workflow that allows you to do that. And then it's all about the integration with the other components. So you will see the hydrogen tank, for example, the valves that come out of that. Very important is the interaction of the thermal system all over here, cooling, and then also when it connects to the electric part and the rest of the vehicle. And then the main goal of such a simulation would be, if we change quickly to the simulation tab, is to have real-time or faster than real-time simulation. So in our case, our bus will drive a predefined route, and we could change, for example, the amount of passengers. This will add additional weight to the bus, and if we run that simulation quickly, you can observe how the bus changes the operating strategy. Does it need to take power from the stack? At the beginning, it just runs on battery only. And after a while, the stack is in operating conditions. So now we see the fuel cell creating the necessary power, charges the battery. We have currently some passengers on the bus. Let's add some more. So this will add some additional load. And yeah, you can see how this works. The rest of the program is, or the outcome is pretty simple, or pretty, yeah, let's say similar to FireM. So we have the same result post-processing tool. Obviously here it's a little bit less about 3D, but more about the time trace. But the infrastructure is the same. You have access to the same material parameters that you also use in 3D. So the material library is exactly the same. You can share materials back and forth. And a big part for the system simulation is also optimization. So there's an optimization tab that allows you to optimize certain operating conditions or geometries. Yeah, to wrap this up, I just want to show what June mentioned earlier, which is our online examples, or what we call the REST box. If we go to up here, we see AVL Resource Box. And this is really a nice online platform that you can access as soon as you have the installation, that gives you on-the-fly updated examples. Just need to log in here. There we go. And yeah, we get a lot of examples for all the tools, but also for topics. These come with extended documentation. Let's go to a Cruise M one, for example. We go there to Cruise M. We have 562 examples here, for example, as you can see. And you can download them. So you don't need to download all of them at once. Obviously, this would be quite some size, but let's take a heat exchanger model, for example, and you will get the documentation, and you will also have access to training videos and also upgrade videos here. So that's both for CruiseM, FireM. You get nice little snippets of videos of the newest features. It's always good to see what's new, and there's usually quite some nice tools also for the fuel cell. Yeah, with that, I'd like to switch back to the presentation for a minute and show you some use cases, discuss some use cases also with John for the remaining minutes, and go into the stack. And John, yeah, this is mainly your domain, so to say, 3D CFD, I would say, right?
Yeah. So I think basically with 3D, we are trying to solve this flow media supply problems, and also try to solve, for example, the water management issues, the local degradation possibilities. So with that goal in mind, so our tool can be applied, for example, in this slides, the cell performance and degradation for the cell, and then for stack, here we can solve this hydrogen and air supply, and then for the heat management, thermal management system, we solve this coolant flow and pressure loss, and then for the stack thermal management applications. Yeah.
And yeah, performance analysis is also quite a nice topic with plenty of validation in the meanwhile for our models. And I'm very happy to see my alma mater school, the Graz here, to give it a quick shout out on the measurements. So yeah, and it really can observe the patterns that happen for different conditions. We see here reference conditions, but also then a high temperature or a humidity of 50%, for example, only for different current densities. You can quite well see how the current density patterns change, and yeah, experimental data simulation in a coarse grid, for example, in CruiseM, and then simulation on a CFD grid, how that turns out. And also some performance analysis for over the length of the channel. So very good agreement in the meanwhile is achievable here for PEM. And yeah, if the slides also will be available for later digestion in peace, so to say, and not in this short amount of time. So feel free to ask us for the slide in the comments. And yeah, big topic, as June mentioned multiple times on the fire side. I can add the degradation models we also use on the system simulation. Actually, there we can simulate long amounts of times and also use it on the test bed. But basically, again, we use the same models on the 3D side as well as the 0D 1D side. And yeah, this is probably a topic by its own. So we might do another lunch and learn on just the degradation topics moving forward. Also, meanwhile, we have quite good validation data for the degradation, both with universities, as we've seen it here, but also with industry partners. Here's the slide, or the slide that shows it in 3D CFD. So really the localized data makes quite an impact on the degradation. So 3D can really help you design this stack and the cooling plates nicely. And for the system, it's much more about the controls development, for sizing of components, requirements definition, as we see it here on the left. Also very, very helpful for component selection. If you have different suppliers, different components in mind, to test this virtually before you start to build the prototype system. System layer and integration is, and also optimization and calibration, both in software in the loop, in the office, but also in hardware in the loop system. This is something that works very well. I will just, for sake of time, speed this up a little bit. And jump to another important topic. I don't think we will be able to cover everything today, so maybe just to finish it up with the PEM electrolyzer development. And here, June, I think we got quite some impressive simulation results in the meanwhile.
Yes, I would agree with that. Yeah, we have this specific developed multi-phase flow for this liquid water flow in the electrolyzer. So we were able to match pretty well with in some of our customer projects with this tool. So this give us a pretty powerful tool to investigate what's happening in the electrolyzer, in the PEM electrolyzer. Yeah.
Perfect. Yeah. Feel free to try it out. Contact us and try it. Or also, if you're a student or a teacher, you have the possibility to access the tools for free. So I will post a link in the comments to access the tool as a researcher. And to wrap today's Lunch and Learn up, I will discuss the upcoming events that will be happening next week and in 2 weeks. The first one is the High-fidelity Vancouver conference. So this will be happening June 17th to 19th in Vancouver. And on day one, there will be a tech tour. So AVL's dedicated office there, AVL FCC, will be part of this tour. So you can access this facility that is focused mainly on the stack development. So they build stack prototypes there, as well as our partner Greenlight Innovation that focuses on innovative test systems for fuel cells and electrolyzers, and is basically a market leader worldwide in that domain. So we will be on site there, and happy to take any questions, also happy to give some demonstrations. And we also will joining AVL at the booth 219 as well as for a presentation at the speakers corner. So hopefully see some of you there. And after that, June 26 to 27 in Houston, Hydrogen Expo is quite a big event. AVL and Greenlight will partner again and exhibit at booth 546. So feel free to contact us there. We will have people from simulation, from engineering, and also from the testing side at the booth to speak to and show you stuff. And also we will be participating in a panel discussion as well as in the fuel cell technology track So yeah, hopefully see some of you there. I think with that, we can wrap it up. And yeah, thank you, June, for showing us the 3D part. And hope to see you in July 3rd again after the break with all the events upcoming. Topic still needs to be clarified, so that's a minor mistake on my end here. But with that, we can conclude today's Lunch and Learn. And yeah, thanks for watching, and watch it again on YouTube if you like to. Thank you, and bye-bye.
Thank you. Bye.
Okay.